Hey guys, Laura Furches here, Tinkering Twins and their mom. I just wanted to show you what's going on with robotics. This is my son Sam, one of the twins, and he is going to show us the CAD. And what does CAD stand for?
Computer-aided design.
Computer-aided design.
Computer-aided.
Oh, computer-aided. See?
Computer-aided.
That's what moms do. They make mistakes with what the kids are saying. All right. So, you want to explain what's going on with the robot and what you did this year?
Okay, so the robot is a improvement over last year's design. Last year and this year, the goal of the robot is to pick up and fire foam balls. Or at least that's the main function.
So, playground balls.
Yeah. Dodgeballs, basically. Not kickball dodgeballs, but like anyway.
Smaller than soccer balls or footballs in England.
7 inches in diameter foam balls.
The Commonwealth. Smaller than footballs in the whatever. Okay, go ahead.
So, the robot would drive over any foam ball sitting, say here, go into this reservoir here. This roller and this roller would be connected by a rubber mat, which acts as a conveyor belt, which brings those rubber balls up through here, out here, and land on this thing here, and gravity feed down to this intake roller here.
Okay.
This intake roller would be driven by a motor that would be over here, but it's not on the CAD anyways. Feed the balls up this ramp, through this ramp, and along the way they'd touch this roller here, which would be attached to this roller here through these pulleys, and some polycord, which would be attached here, which would be attached here, which would be attached here, which would be attached here to this motor here. This all spins, as you can see, if I can zoom in a little bit. Together, and any balls that touch this will go out there.
Alright, and so, hang on a second, let me zoom back out a little bit. So the target is where?
Target would be about 8 feet.
Let me find my...
8 feet high in this direction.
Okay, so where my finger's pointing, but, over to the distance a little bit.
Yeah.
Okay, cool.
So the maximum distance between the robot and the target would be somewhere around 20 to 30 feet. I can't remember the exact number, but
wow, so that's powerful. Launcher then.
Yeah, this motor packs a punch. Anyways, so this launcher would normally be at a set angle, but with the power of this window motor, which normally drives car windows, drives this sprocket, which drives this sprocket, which turns this bar here, which is attached to this hub, which is attached to this hub, which is attached to this and this. The angle of this launcher can move up and down. The functionality of that isn't working right now, but I assure you it does work.
The foils and toils of working on a robot.
The CAD is very sketchy. It does actually work on the actual robot, but...
Oh, it doesn't work on the CAD. Okay, yeah. Gotcha.
Anyways, so that's the basic function of what we've done with the launcher. We've also got this vision tracking camera here. It isn't actually positioned how it would be. It's at an angle, and
so that camera is to aim the launcher.
Yes.
Then
yes, using some sophisticated algorithms and
so
science.
If I can, I'm sorry, my finger was, my camera angle was off. We weren't in frame, but anyway, this is the camera that would aim the launcher so that it would be good on target. And that's something my other twin had recommended last year, and we were able to accomplish this year.
Anyways, you'll notice that these wheels are quite interesting. They have wheels on wheels. So, the basic function of this is that normally wheels rotate in one direction, they move forwards and backwards, and if these two rotate in the opposite direction from these two, the robot turns. Normal wheels. But what is interesting about these is instead of these two being connected, these two are rotate in the same direction, and these two rotate in the opposite direction.
Okay, so I'm sorry. Let me zoom out a little bit. And these two roll in one direction?
No. Say this and this are counterclockwise, and this are clockwise.
Okay, so let me see again. Oop, could you go back a second?
Like here?
Yeah. So this one and this one roll in the same direction?
Yes.
And then
This one and
that one and that one roll in the same direction. Gotcha.
And if that happens on normal wheels, normally the robot wouldn't move. It would just lock up in place. But
yeah, I mean, if you're going in opposite directions, that.
But these smaller wheels, they allow the robot to instead transform that locking direction into strafing, which is moving laterally along this direction. So if they were moving, say, counterclockwise, and clockwise, I think the robot would move in that direction, directly to the right.
Back and forth on the y-axis instead of just x and z.
Z being the rotational turn.
Yeah.
Not vertical.
Right.
The actual z direction of the robot.
Ooh, they have rockets on their bottom of the robot, and they can go vertically. Ha ha ha! Well, wouldn't that be awesome?
This here accomplishes basically that, except instead of pushing, it's pulling on, say, a bar that would be, say, up here.
Right. Okay.
There's these very, very large and very, very expensive pistons that push this mechanism up here approximately 2 feet, which hooks onto a lateral bar, and then when these pistons retract, then these hooks attach to that bar and lifts the entire robot up approximately 2 feet for 30 or so seconds.
Wow, that's awesome.
Yeah. But that's exactly the same as it was last year.
Right. But most people on my channel are not going to know that. But anyway, what was I going to say? I can't remember. It's all right. Sorry for the dog barking. Cool. So that's what they've been working on, and we'll have pictures soon, or a small video clip of the robot. So,
let me see if I can get the, hold on. Can I get this working? No.
It's alright. People on my channel are gonna get the gist of it. Sweet.